Hello everyone, welcome to Biotech Easy. I'm Saloni Dubey. I have worked as research associate in MGM Medical College as and MedGenome, and today I'm going to discuss about SDS Page practice questions as well as two-dimensional gel electrophoresis, isoelectric focusing. So in two-dimensional gel electrophoresis, what happens and why it is required? So in 2D gel electrophoresis, proteins are separated in two sequential steps. First is on the basis of their charge. Second is on the basis of their mass. Why it is required? First, it helps us to separate proteins that differ by only one atomic mass unit. Suppose two proteins are there. One has atomic mass of 41 kilodalton, another protein has atomic mass of 42 kilodalton. So these type of proteins can also get separated by two-dimensional gel electrophoresis. Second reason is proteins having same molecular mass can be separated based on their isoelectric points. So this can also happen that two proteins may have same atomic mass but different isoelectric points. What are isoelectric points? Isoelectric point is the point where a protein has a net zero charge. So in gel electrophoresis, what we use electric field. We apply electric field. One side it is positive terminal, another side it is negative terminal. So if something is having zero net charge, where it will migrate? It will not migrate to any of the terminal. It will get immobilized. So this is what isoelectric point serves. It is the pH where the protein stop migration because it gains a net charge of 0. In isoelectric focusing, there is one strip that has a pH gradient. So here you can see I have written gradient of 4 to 10. So on this pH strip, also not pH strip, on this isoelectric focusing strip, the pH changes at every point. At one side it is positive terminal, another side it is negative terminal. So protein is loaded on it and it start migrating under the influence of electric field, and whenever its isoelectric point arrives in this gradient of 4 to 10, whenever the protein's isoelectric point arrives, the protein gains a net charge of 0 and it stops migrating. It get immobilized. So after the run is complete, it is loaded on a second gel, and here it is SDS page. So here you can see at this lane two bands have or 2 points are there. It means at this particular pH there are two proteins got immobilized at this particular isoelectric point, or we can say pH. But on SDS page they have migrated at a certain distance but in the same lane. Why? Because this protein has same isoelectric point as this protein, but this protein has higher molecular mass, this protein has lower molecular mass. So we can separate proteins which have different molecular mass but same isoelectric point by two-dimensional gel electrophoresis, and we can also separate proteins which have same molecular mass but different isoelectric points. Here you can see these two proteins have same atomic mass because they have migrated to same distance on SDS page, but on isoelectric strip they have migrated at different pH, or they got immobilized at different pH. So this is one of the advantage of two-dimensional gel electrophoresis. Let us come to the questions. Let's solve some questions. First question is, four proteins with the following isoelectric values were separated by isoelectric focusing. So here they have given four proteins and their isoelectric points, means these are the pH where the protein will get immobilized: 3.6, 2.9, 7.2, 6.5. They are asking that what is the order of their migration from anode, means the positive terminal. So what is the order of migration from the anode? Means which protein will be closest to the anode, which protein will be farthest from the anode. So let us see how to solve this question. First of all, you should keep one thing in mind, that anode is positive terminal, cathode is negative terminal. And here they have not specified a particular pH, so we will take pH 7 only. and we have to apply this formula, that isoelectric point of protein minus 7. So for each protein we will do this. We will subtract 7 from the isoelectric points of the protein. So protein first has isoelectric point of 3.6. So 3.6 minus 7 will come minus 3.4. 2.9 minus 7 will come minus 4.1. Similarly, for other proteins we have calculated. For protein third it is plus 0.2. For protein 4 it is minus 0.5. So minus 4.1 is more negative. So it will migrate more towards the anode, which is positive terminal. Plus 0.2 is more positive. So it will migrate more towards the cathode, means negative terminal. So what will be the order of migration? Protein 2 will be closer to the anode, followed by protein 1, protein 4, protein 3. So the correct option is C. Means the order is 2, 1, 4, 3. This is the correct answer. Now question 2 is, if you run a pentavalent IgM through SDS polyacrylamide gel electrophoresis, how many bands you are supposed to get by Western blotting using alkaline phosphatase conjugated secondary antibody? So what they are saying is, we have a IgM antibody. We have ran this IgM antibody on SDS page. Here they have mentioned just SDS page. SDS page means there is no denaturing agent. Not denaturing, there is no reducing agent. So what is the reducing agent? Beta-mercapto ethanol. It is absent. What is the role of beta-mercapto ethanol? Beta-mercapto ethanol reduces the disulfide bond. So in simple language, it breaks the disulfide bonds. And if you remember the structure of pentavalent IgM antibodies, how it looks like, 5 subunits are there and they are joined by disulfide bonds, and J chain is also there. So these disulfide bonds are present, and if you run this on SDS page, it will not get denatured. So all subunits are together only. So how many bands you will get? You will get only one band. So here I have written the reason also. Here we are using only SDS page that does not has beta-mercapto ethanol. In absence of beta-mercapto ethanol, disulfide bonds will not get reduced or broken. So we will get a single band. So the correct answer is the fourth option, which is 1. One band we will get. Question number 3. A small fraction of cellular lysate was run on an isoelectric focusing gel IEF to purify a particular protein, which showed a number of sharp bands corresponding to different isoelectric values. The protein of interest has isoelectric point of 5.2. Therefore, the band corresponding to isoelectric point of 5.2 was cut, eluted with appropriate buffer and subjected to SDS page, which showed 3 distinct bands. So in this long question, what they are saying is, they have some lysate, they have done isoelectric focusing for it, and their protein of interest is at 5.2 pH. So they have cut that band, and that band only they have ran on SDS page. After running on SDS page, they got 3 bands. And now they are asking, which one of the following inferences cannot be drawn from the above observation? After describing all this activity, they are asking that out of these 3 options, which is not true? Which is not a true observation, which we cannot say that this we can infer, this is the result of this observation. So first is, several different proteins having same isoelectric point may be present at the single band on IEF gel. This is true. This I have already explained, that different proteins may have same isoelectric point, and after the run is complete, when we run it on SDS page, we will get 2 bands according to its molecular weight. So this is true, that maybe different proteins are there but they have same isoelectric point, so they got immobilized at 5.2 pH, but when we ran SDS page, we got 3 bands because these proteins have different molecular weight, so we got 3 bands. This is true. Second is, SDS page showed 3 distinct bands which may represent molecular mass of different proteins. Well, this is also true. The same thing, the first statement is also saying the same thing. Now third statement is saying, As the IEF gel showed a distinct band corresponding to pi, means isoelectric point of 5.2, which is the pi of the protein of interest. The protein is composed of a single subunit. This is not true. They are saying the protein is composed of single subunit. This is not true. Why this is not true? Because we got 3 bands on SDS. If the protein is composed of single subunit, then we should have got single band only, but we got 3 bands. So therefore the third option is not true, or we can say it cannot be drawn from this inference, cannot be drawn from the above observations. Fourth question: the molecular mass of a protein determined by gel electrophoresis is 120 kilodalton. When its mass is determined by SDS Page with and without beta-mercapto ethanol, it is only 60 kilodalton. What is the most probable explanation? So here they are saying that by one technique they got protein at 120 kilodalton, but by SDS Page and by reducing SDS Page also, they got same result, and the result is what? They got a single band at 60 kilodalton. So they are asking what is the probable explanation for this. Let us see the options. First option is protein is a dimer in which two identical chains are cross-linked by disulfide bonds. This is not true. Why? Okay, for one condition it may be true that we have used beta mercapto ethanol, so the disulfide bonds are broken and we got two bands of, or we got single band of 60 kilodalton. But what, why we got 60 kilodalton band on SDS? SDS cannot break disulfide bond. So if the protein is a dimer having disulfide bond, then it will migrate, it will not get broken, and it will migrate, and it will come at 120 kilodalton only. So this first statement is wrong. Second, protein is a monomer of 60 kilodalton but is excluded from the gel matrix. This is incorrect. They are saying that protein weight is 60 kilodalton and it got excluded at 120 kilodalton in gel filtration. This is wrong. Third statement is protein is most likely to be composed of two subunits having identical molecular mass. This is true. Why this is true? Because on SDS Page, where we are not using any reducing agent, there also we got a single band of 60 kilodalton, as well as when we used SDS Page along with the reducing agent beta mercapto ethanol, which break the disulfide bond, there also we got 60 kilodalton band. It means that protein is a dimer of two identical subunits, 60 plus 60. So the total will come 120 kilodalton. So this statement is true. Fourth statement is protein is a monomer but it is picked into half its size by SDS. No, this is not true. So let us see that what SDS do. So SDS is an anionic detergent, means it imparts negative charge. It has negative charge and it gives negative charge to the protein. What it does is it denatures secondary and non-disulfide linked tertiary structure. So this is the role of SDS. So why I have written this, because I just wanted to tell you that SDS does not break disulfide bonds. I hope students that you have gained deep understanding regarding sodium dodecyl polyacrylamide gel electrophoresis application based questions, and how to solve it, and how to solve questions which are based on isoelectric points. And if you like it, then please do share and subscribe my channel. Till then, keep learning and be an explorer. At Bye Tech Easy. Bye Saloni. Thank you.